Okay, so this is homework number 8, and here are some extra tips and guidance if you get stuck to help you complete the homework. So this question is looking at the ability of these substances to conduct electricity. And what I'm going to say to you here is to think about the type of bonding that exists. So I'm going to put a little column, type of bond that exists within these substances. Okay, so for example, water, you should know, is hydrogen and oxygen, H2O, and two nonmetals, and therefore it's simple covalent. And because it's simple covalent, you should then know the properties and why it has those properties because of the way it bonds. Solid sodium chloride, this one here is a metal and a non-metal, so that's going to be ionic bonding. And then the very bottom one is also ionic, but there's a warning here. This one is in solution, so that means something else in terms of what has happened to the ionic compound. There are 6 marks to this question, as you can see there. This needs a lot of information, so if I was going to do this response, what I would do is I would have a section on water, and then I'd write my response to water, and then I'll do a second section on the solid sodium chloride, and a third section on the sodium chloride solution. And that way you break up your answer for somebody to understand. Okay, moving through the paper. Question 2 here. What you've got to do here is explain why copper as a metal conducts electricity. So here's my little model showing you the structure of copper. So you've got these metal cations, and they're surrounded by a sea of delocalized electrons. I'm actually going to put in there, to help us, some positive charge, mainly they're cations. And from that information, you should be able to work out why metals are good conductors. Coloured compounds. We haven't really covered this much in class. This is a bit of knowledge just to stick away and store in the memory. The type of metals that form coloured compounds exist in the middle of the periodic table over here. And this region of metals are called the transition metals. And you'll find copper is inside this region. So here we've got some information on ions, and it wants us to work out formulas. Remember, when we work out formulas, we can take the chemicals and the charges on them and use that to tell us how many bonds it wants to make. So this wants us to give the name of calcium nitrate. So that means it's going to be calcium, which is Ca2+ according to the table, and nitrate is NO3-. And what you then need to do is underneath, this wants to make 2 bonds, that wants to make 1 bond, and then you need to swap those over to work out the correct formula. This next question is about counting atoms. I'm going to have a go at it yourself, because hopefully we're getting that confidence now to be able to count those atoms. Just watch out. There's a 2 outside the bracket. Think about what numbers outside the brackets do to the things inside the bracket. Okay, number 6. Number 6 is describe how these are going to form charges. So what we need to do here is remember that if you have 11 electrons, you are going to be 281. And if you've got 16 electrons, you are going to be 2, 8, and 6. And then think about how these can become stable by giving and taking electrons, and what that would look like. That's my hint for you. So how can they become stable in terms of transfer, giving and taking electrons? Okay, you should be able to this one. Remember, it's group 1. Remember, groups go up and down in the periodic table, so use that to help you with that. Working out relative formula mass. To work out the mass of a formula, all you have to do is you add up all the bits in the formula. So here I can see I've got 2 lots of carbon, and I've got 6 lots of hydrogen. So carbon's mass is 12, we're told that here, and hydrogen's mass is 1. Work that out, so that's 24 and 6, and that's going to be a total of 30. So use the same method for each one of those, and you'll get them Correct. Okay, this one is working out the mass of a number of moles. Now to do this, we need to remember that Mr. Moles is underneath the mass. And we're trying to find out the mass. So if I write down in here that the mass is equal to mR times moles. So the mR we can see is 98 and the moles from the question is 0.5. So on my calculator, I'm going to do 0.5 times by 98, and that's going to be 49 grams. Next one, how many moles are there? So here, if we're going to work out moles this time, so let me just get rid of that circle. Now we're going to work out the moles. So if I work out the moles, we have got mass divided by the mR. So let's write that down again here. So we're working out the moles. The moles is mass divided by the mR. The mass in this case is 24. The mR in this case is 9. 24 divided by 9 is 3 moles of that one. Okay. Next one, number 11 is how many oxygen atoms are there in 2 moles of O2. Now remember, if I've got 1 mole of O2, that is 2 moles of atoms because it's O2. Therefore, if I have got 2 moles of O2, I will have double that number. So I will have 4 moles of atoms. And then think, how do I work out the actual number of atoms? How do I use Avogadro's constant to work out the number? Next one, I'm going to let you try yourself because of what we've done in number 11. And that is the end of that particular section. Good luck with the homework. Do your best. Make sure you use the video to help you. And we'll mark it when it's complete.